Hello. In this video we're going to do a quick discussion of classic rate problems as they're found on the SAT. And we know we're going to be dealing with a rate problem whenever we have something, the format is pretty much always the same. It's going to state some person or thing can do a certain job or prepare something in a certain period of time. And then typically what it's going to ask is it's going to ask how long would it take all of them working together to complete a certain task. Okay? And our master formula always is this. It's that dreaded distance. Distance equal rate times the time. Sorry, my hand's a little cramped today, so it's going to be extra fun with the with my squiggles. But anyway, okay, so this is what we've got. That D is bothering me. Try to clear that up a little bit. What was supposed to be a D? Okay. Yeah. So distance is equal to rate times time. Now, in this scenario, though, what we want to think of as the distance is, distance really is referring to what was accomplished, right? Like how far did you go, how many tasks did you complete, yada yada. Well, in this case, they're all trying to prepare a solution, right? The solution, they can prepare the solution in a period of time. So we could think about the task really is just one. It's one thing that we're trying to do. So our distance is 1, and we have different rates and times for each one. Well, let's just look at this for a minute. It says Johanna can do, either Johanna or Elizabeth can prepare the solution in 6 minutes. That means the time that they need to finish this job, the T, is going to be 6, right? So it's 6, and then it's just, their rate is, they didn't specifically define it, but we can just say, let me say rate of, what is it, Johanna, put a little J down there, is equal to this. Well, if we want to solve for the rate of Johanna, all we'd have to do is divide both sides by 6. So Johanna's rate is equal to 1 over 6. And again, all that means is that you figured out she can complete one task in 6 minutes. Okay, and the same logic goes for Elizabeth. They said she's also 6 minutes, so her rate Elizabeth, is also going to be 1 over 6. And it says Dan can do it in 4 minutes, so his rate, let's see, the rate of Dan is equal to 1 over 4. Okay, so now we have all the rates, and all we have to do is add them up together. Okay, this is all this is going to be. Basically, the result is we're still using, highlighted in green, we're still using this master formula, but now we have 3 rates working together. So we really have this. We have the rate of Dan times his time plus the rate of Elizabeth plus times her time, right? Again, I'm just expanding on this RTD formula, plus the rate of Johanna times her time is equal to the distance, or whatever was completed. Well, again, we already know all these things, or everything that we need to solve this, right? Because we know that the distance, we're trying to find one solution, so that's just 1, right? How long does it take them working together to complete one task? And we know all these rates here. We know the rate of Dan is 1 over 4, so I'm just going to put that in there. That's 1/4 his rate times the time, and plus, sorry, my handwriting is very scattered today. And then filling in the other ones, we know the rate of Elizabeth is 1 over 6 times the time, plus the rate of Johanna is also 1 over 6 times her time, and that all has to be equal to 1. Well, and it says they're working together, so presumably the times are all the same, right? It's not like Dan starts first, and then a little bit later Johanna jumps in, and maybe then later Elizabeth, which, though, actually, if you think about it, you could set up an equation to solve for that, but more on that later. But yeah, so here's what we're going to do. We just have to solve for T. How long, right? How many minutes will it take for them to work together? So that's just T. Easiest thing to do first is get rid of the denominators, right? It's tricky to work with fractions, so let's just multiply both sides of this equation by something that would cancel off these fractions. The smallest number I can think of is 12, right? That's the least common multiple of these bases here, but then I got to multiply this side by 12 too. Okay, so if you do that, you just run through that real quickly, that would get me to, looks like 3t plus 2t plus 2t is equal to 12. Okay? Well, and then finally, we can just add all these t's together. They're all like terms, so we have a total of, looks like 7 t's. So we have 7t is equal to 12, and then to solve for t, divide both sides by 7, and that gets us the t is equal to 12 over 7. So the amount of minutes that it would take would be just under 2 minutes if they're all working together, right? And that would be our answer here. The answer is C. Again, the steps for this, anytime that you have a rate problem where you have multiple people or processes working together, you just have to figure out what is the rate for each one individually, and then you just take each of those rates, put times time, just expand that basic distance equals rate times time question, and plug in your numbers and solve for t. Okay? Hopefully that was helpful.